My name is Vangel and I'm come from North Macedonia. I am assistant professor, associate professor at the largest department where we have computer science as the main discipline of the studies. We have about 4,000 students. In total, we enroll 1,000 and a bit more, 1,100 students each year. Since all these students are, I will directly skip to some of the discussion of the problem. Since all of the students have many courses to choose, many disciplines to sub-disciplines to choose, and because of great unemployment issues in the country, we have been constantly allowing all students to work in parallel to studying. So they're just regular students. We don't have part-time studying, but in fact, we are flexible about it, and we do allow students to choose what their track is going to be, how fast they will be going to study, etc., etc. So this creates many issues how to track this, the status of studies and the status of the study programs, and what kind of new innovations to do in the curricula. But we always try to have recent and modern and innovative curricula regularly. So we had many curricular revisions. Some of them are noted here, which creates a lot of issues. Creates issues with us not knowing how many students are there in each direction, how many students are there in each program, because the students are allowed to skip from one to another side. Another issue that is going due to this, due to the enormous number of changes, is that every student has a right to stay within the study program for at least 8 years and maybe even more if we allow them so. When you have, let's see here, 2011, 2013, 2014, let's say every 2 or 3 or 4 years we have a new curricula, and due to this right of the students, we have to take care that all the relevant courses that each student should be able to enroll are still active. So we have, since now it's 2020, we have active courses from 2018 program, from 2013 programs, from 2000, some even from 2011 programs. And we have many programs. There were 8 total study programs in 2011, 8 new in 2013, 4 new in 2018. That means that we currently have active, as you can see, too many, so 20 study programs at the moment. Most of the courses are similar in these study programs, but due to the innovation that has occurred and evolution of the material and the approaches, we, as a teachers, we constantly have students from various backgrounds, from various study programs, at the same time studying the same course, but a slightly different version of the course. So to track all of this, you need a special system, and this is the demonstration of this system. The initial vision for all this work was to be able to have a view that corresponds to some of the curriculum guidelines made by ACM and partner associations in defining the body of knowledge in some discipline, and then defining the areas of knowledge, units, and topics that should apply within those units. So the idea was to be able to have some kind of mapping, what each student learns, what the teachers research, what do they know, what do they propose, what do they teach, and have a mapping through all this. Since there is too much data and too much initiatives and innovations going on at the same time, this starts to become like a very complex issue. And one of the ideas that was employed for this research and this line of work that I have also presented in the COLI conference last year was a method that originated from an idea 10 years ago, also presented at this conference, to automatically map the topics and the areas of each study program and each of the curricula that are offered to students. So that is the main idea. Some of the works are here. I will just skip this because I will leave the presentation in the forum for you to view later on if you are interested. So the idea was to gather all the data from the evolution of all curricula and guidelines, how the body of knowledge should look like. The guidelines have 18 knowledge areas and 163 knowledge units. And we have a data at our university, to be more specific, at the computer science departments, about 3,130 course instances that have occurred over the last 20 years over 3 institutions. So this system is built to be used by many institutions, and if they have joint programs or joint courses, they can be partners, or if they are not, they can be tracked individually. So this amount, all of this data was then processed, cleaned, translated, because our official language is Macedonian, the guidelines are in English. We had to have some standardization to be able to do the mapping. So everything was, I have translated everything in English, mainly using automatic translation and then revising manually everything that didn't translate too well. And then there was a cleanup, boilerplate text that should be removed, descriptions, the structure, syntax, etc., etc. And after that, what I got to was a body of text that represented the curricula through all the evolution of our institutions over the 20 years, and the documents from the curricula guidelines from ACM for computer science. So then the idea was, as described in the paper by colleagues 10 years ago, was to employ latent directly allocation and ISO map to get to 18-dimensional space, and then to get down to 2-dimensional space and create a map, and from there build on to do everything. So the results are represented here in several slides. I will go directly to the, sorry, I have to do it like this. So this is the map. In the background, various colors represent the knowledge areas defined by the ACM curricular guidelines. These are the curricula for one of the study programs, the active study program, computer science. So we can see when, at this point of the evolution of study programs in 2013, where did, for example, algorithms and data structures lie? In other study programs, the content was slightly different, and it would lie a bit more to the right. And we can so compare the various instances of study programs and various instances of courses one by one. Besides this, we also have in the system a view that looks like this, that they represent the structure of the study program. But this is a general graph, and we use many kinds of links between the nodes. The nodes are the curricular or the specific instances of courses in that study program, and the various dashes or types of line or colossal lines represent various types of prerequisites or other types of association. For example, we can check that this course has been in the past implemented like this, and when innovated, it turned out like this. So in this case, in this sense, through the monitoring of the structure of the graph and viewing various snapshots over different parts of the graph, we can inspect how the structure of the courses of the whole study program and the curricula have changed. And this graph can also be mapped here, but I don't do it because it will be too complex. Because here everything here we see the structure, how it all goes into the first year, second year, third year, fourth year, and here it is by mapped by content, and the links would go to all various directions.